So again, I'm Thomas Edwards. I work for PBS during the day doing broadcast engineering over satellite. And in the past, I've done a lot of various animatronic and mechatronic robotic works, mainly interactive works. You may have seen my stuff at Artomatic in the past. Little heads that follow you and say hi to you and things along those lines. Fish that cry out and paint on the wall. For this project, I've been getting more interested in the world of telepresence. And that's good we have at least one telepresence person back there. Let me talk a little bit about telepresence. There's a long history in artwork, both sensoral to sensoral, which I'm going to call sense-to-sense telepresence. And there's also been a lot of sensoral to physical telepresence. I call it sense-to-Phy telepresence. It all kind of started way back in 1940 with a Heinlein short story about Waldo F. Jones, who was a genius who suffered with disabling disease, and because of that, he built himself a zero-G home in space where he was able to telecontrol robots down on the Earth, robotic machines called Waldos. And then in 1980, Marvin Minsky came along and in a work called Telepresence coined the term telepresence, although he claims that futurist Pat Gunkel is actually the person who came up with the initial word telepresence. But if we look even farther back, we can go all the way back to just after World War I. Dada artists were beginning to do work where they were sending telegrams as art, which is really kind of the very first telepresent artwork. Then in 1922, Laszlo Moholy-Nagy, I hope I'm pronouncing that right, used a telephone to order 5 paintings, and that was considered the first telephonetic artwork. Then in 1969, at the Chicago Museum of Contemporary Art, they had an exhibition called Art by Telephone, which is probably the first example of crank calling art. They got a list of people named Arthur in 20 different cities, and they called these random people named Arthur and asked for art. And then a conversation kind of went on from there. So you can see this whole concept of using telegrams, telephones, radio, television for artwork came a long time down the road before the internet was even anybody's dream. Now, more recently, there's been a lot of very neat stuff going on in telepresent art. This is some work by Paul Sermon. Paul Sermon has done a lot of things in the early 90s and some more stuff recently, which involved the use of kind of chroma key video and then sending video over distances. And you can see in the top, here's a real person. There are people with hands around, and then it's reflected kind of a chroma key on top. Here's another work called The Public, where here's a real woman sitting chroma keyed between 2 remote participants there. Meanwhile, Eduardo Katz has also done a lot of similar telepresent work. Here's the top is a work called Dialogical Drawing, where it's basically a speaker and a microphone, and the 2 sides are distant. They could be in any city, connected, I believe, by a telephone line. And basically, if people come up to the work and they look at it and they're like, hey, that's kind of an interesting looking work. It looks like a circuit board. But then on the other side, people hear them saying, hey, look, that looks like an interesting work. You're like, hey, is there anybody there? And they're like, yeah, there's somebody here. And they talk back and forth like that. He also did a work called Rara Avis, where he has a teleoperated macaw, which has video cameras inside its eyes, which send video back over the internet using a technology known as CUCM. And Ken Goldberg, who I'm sure a lot of you have seen some of his work, he's done a lot of things, including like 2 heads that talk to each other back and forth. He did a work called the Telegarden, and this was a web-operated garden. So you would go onto a website, and you could control this robotic arm to move around the garden, and you could plant seeds, or you could mess around with the soil, or what have you. And this was actually operating from 1995 until 2004. Again, kind of a sensoral through the web interface to physical with the robotic actuator on the other side. But I want to go beyond this whole sensoral to sensoral or sensoral to physical telepresence. I want to go to physical telepresence. I believe it's time that we move to that next level. So in order to kind of nurture the creation of physical to physical, or what I'm calling Phy2Phy projects, I've started a new site called Phy2Phy, which is on wikidot.com, where folks can come in and they can share the projects they've been working on, and they can get pointers on how to build Phy2Phy works based on embedded microcontrollers. And I've got two major goals for these projects. The first is that they've got to be cheap, because nobody's got enough money these days, right? And secondly, it's got to be easy, because nobody's got enough time these days either. And the truth is, in the year 2007, we've really reached a point where doing simple network embedded stuff should be very trivial. This shouldn't be all that complex. So Phy2Phy, the project is based primarily around two microcontrollers. The first is the Arduino, which is the open source, open hardware system. These boards can be either fully built, maybe in the $30 range. You can get a very bare bones kit for about $15, so it's not very expensive at all. It's based on the Atmel ATmega microcontroller. It's programmed in a very high level language that's easy for people to learn. You don't have to know machine language. If you've done Pascal or C or Java or even JavaScript, you probably can figure out how to use this language. There also is the CuBlock from Compile, which is actually what's in my work Touch. And this is, again, another ATmega microcontroller. It's the same microcontroller, but it's programmed in a basic language. It's probably a little bit faster. It's a commercial product, yet not open source. It's all proprietary. It's a little bit faster. It's got some more features than the Arduino, a little bit more expensive as well. These are both very good options, depending on what you want to do. And then you have to talk over the internet, because again, it's not really telepresence until you're really getting out there and networking. Two great solutions include the Lantronix exports, which now exist in two different types at least. There's a regular export, which is the one on the top. And again, it's just like just a little Ethernet connection. It's got a couple of pins on the bottom. It goes from Ethernet to serial, and serial to Ethernet in a very simple way. It's very easy to use. There's now a cheaper version, which I think is just about, it's a little under $30 now, called the Export Direct. It's got it's a little more complex to interface to physically, but again, it's fairly cheap. It's only about $30. So for $30 for the Ethernet, $30 for the microcontroller board, $60, and you've got half of your telepresent device right there and good to go. There's a new product that just came out which uses an ARM microprocessor called the Ceridium ARM Web, and this is a whole $100 board down here, which has a built-in Ethernet connection. I'm looking into this. This sounds very interesting, especially for telepresent products that might need a little bit more power than the ATmega can deliver, and the ARM is a very powerful microprocessor. And so once you've got your microprocessor or microcontroller board and you've got your Ethernet, then you need your sensors. You need sense in order to sense the physicality. And then on the other side, you need your actuators. You need to do something physical. Here we've got examples of sensors. We have force sensing resistors, which are like what's on the Touch. This is a piezoelectric sensor. This person has mounted it to a ping pong paddle, so when the ball hits the paddle, the strength of that impact comes through the piezoelectric sensor. This is a thermal sensor. If you want to sense somebody's warm hand is on something, you could use that. On the other side, you have actuators. You have the RC servo, which is very cheap. $10 gets you a perfectly good servo, very easy to use. You've got your good old windshield wiper motor, about $15. Very powerful little gearhead motor, very easy to get, runs on 12 volts. These are air muscles, and this is in its non-extended state, and this is in its extended state. And basically, you mount it to like an arm or something like that. In the extended state, if you apply air to it with a pneumatic device, it then shrinks to that size, and you can use that to like move an arm back and forth the same way you'd use your normal muscles. That's a little more complex to utilize, but again, there's plenty of actuators out there to build your Phy2Phy devices. Okay, so now let's go on to Touch. So the other side of Touch is in Toronto. And let me see. Hold on a second. This is whenever you do demos, it's always exciting. I'm going to call Liab Corin, who's at the University of Toronto, and we'll call him on speakerphone. Liab,
Yes.
All right, you're there. Okay, push up, Leon, push up.
Okay, I'm over here at the box.
Yes. Okay. Okay, who would like to volunteer to touch Liav over the internet? Oh, we got a volunteer. So I think she put her hand up first. Come on up here. Okay. Now she's right there on the fingertip. If you can press down on the fingertip, press down a little bit, and Liav, can you push back a little bit? Feel Liav there?
Yeah.
I'm sorry, what's your name again?
Cat.
It's Kat. This is Kat who's pushing back at you there, Liav.
Okay.
Liav, how many folks are with you in Toronto?
Just one.
Just one, okay.
Yeah.
We've got, what, maybe about 40, 50 people here?
Oh, that's great.
Oh, there's 34 people.
There are 34, okay. My numbers were slightly inflated. 34 people. Okay, somebody else want to try it? Anybody else want to come up here? We're gonna have another volunteer come up. Oh, come on, somebody's got to volunteer. Yeah, go ahead, do it. Oh, I'm sorry, what's your name again?
Colin.
Colin? Okay, this is Colin. Colin's gonna push down at you, Leah. Again, push back at him. Ooh. So there you go. So the data from this is not just going the 250 or 300 miles to Toronto. It's actually... I'm sorry, go ahead, Leo.
I just asking if you're going to post the box.
I'm sorry, I didn't understand.
I was just asking Jesse over here if he wants to post the box.
Oh yeah, you should let somebody else try it. I guess bring up one more. We need one more volunteer before we close this up. You gonna do it? Okay. Mike's gonna do it. Okay, we're gonna have Mike give you Matt. I'm sorry. Give you a push.
And this has given you a poke.
Okay.
This is kind of bad.
You can go ahead and give it a push, hard push on that. Yeah, there you go. We'll get to that in a second. It's ironic you mentioned that. I made a discovery a couple of days ago. Okay. Okay, Liav, is everybody there giving it a shot?
Yep.
Okay, great. I think we've just about done it here. Is there one more volunteer? Oh, okay.
I was wondering if you were aware that about 10 years ago, the Japanese had a tug of war over the area.
Oh, okay. Okay, well let me say goodbye. Let me say goodbye, Liav. Hey, Liav. Thank you very much for participating.
Wave bye-bye.
Wave bye-bye, everybody. Here, I'll push you down one more time. Hey, there, you push it up. Go ahead and push it up. Yay! All right. Thank you very much, Liav. Bye-bye.
Bye, Connor.
I'm going to have to tell them about cell phone service. Okay, anyways, let's get back to where so you said they did a tug of war.
Yeah.
Okay, I'll have to look that up. So I designed the system to be fairly easy to use, although as it turns out it is harder to use here than it was at my house. It DHCPs an IP address. This is all built into the export. Once it DHCPs an IP address, anything the microcontroller sends over the serial connection to the export goes to a predefined IP address which you put in the export. So you say to the export, send every serial byte of data that comes through using UDP, for instance, to this IP address, and it goes to the server. So it goes out to California to the server. Now I've got a little Python program running there which intercepts my packets, my pressure packets, and the pressure packets coming from Toronto, and basically determines who's pushing harder, and then pushes a new position back to both of our fingers. And for my side it goes up, and for his side it goes down, and vice versa. So actually these packets are making about a 4,000-mile trip between here and Toronto by way of California. So I don't know what the delay is in that for UDP, but it's probably only a couple hundred milliseconds. The export can also do TCP connections, but I find UDP just a little bit easier to handle for this type of telepresent interoperation. So meanwhile, let's go back to...
Is there any particular reason you use Python?
Yeah, I like it. It's my wife's fault. She got me started on this stuff. I used to be a like Visual Basic kind of guy. But yeah, so as it turns out, one of the things you learn doing technological art is no matter what you have done, someone has done it before. And I think this is probably the same. No matter what you paint, someone has probably painted. If you painted a mountain before, so if you paint a mountain, someone has painted a mountain before, right? You paint a naked woman, somebody's painted a naked woman before. You paint the Eiffel Tower, somebody's painted an Eiffel Tower before. As it turns out, in 1986, there was a telephonic arm wrestling. And actually, ironically, it also went to Toronto as well, between Paris and Toronto. And these were folks using a system which delivered an analog signal over a telephone line in order to do arm wrestling. And as if that wasn't bad enough, just a few days ago on the Arduino forum, someone informed me about this. There actually is a haptic arm wrestling machine which is deployed at 6 science museums, including New York Hall of Science in Queens, Tech Museum in San Jose, which I didn't see it when I was there last, so it must be in the back somewhere, and the Imaginarium in Alaska. So there actually is an IP based arm wrestling machine out there. So, but still, this is my project. I like what it does, and this is the beginning of Phy2Phy. And if anybody is interested in working on other Phy2Phy projects and doing breath to breath, and doing heat to heat, other types of pushing to pushing, massage to massage, pin to pain, the slapping over IP, which is that's how this all started. I was talking to folks in Toronto about this, and we had a few drinks, and they're like, "Yeah, we could slap people over IP." Like, yeah, that'd be very simple. Just go to, again, it's phy2phy.wiki.com, and I'll put it in the Dorkbot announcement message, which will follow up this meeting, and you can go ahead and check it out and give it a shot. So thank you very much. Do we have any questions? And go ahead, Kat.
How are you arm wrestling 6 people at once, or is it just one of the other people back?
I don't know if I don't know what those arm wrestling machines do. I think it only allows you to arm wrestle one person at a time, but it might be from the different museums. But
what kind of actuator were you using, and how strong is it? And is it linear in how it's? In other words, if someone's putting 1 pound of force, are you getting 1 pound of force out, or how does that?
the question was, what type of actuator am I using? This is an RC servo. The $10 RC servo Phy2Phy S3003. And basically you tell servos what their positions are. You don't actually tell them what the force is. So I measure the force on the resistor here, the force on the resistor in Toronto at the remote end, and then measure the difference. And I've actually had to kind of limit that to a very small difference. If I didn't limit the amount of differences, it gets these nasty oscillations where it goes wild back and forth. Yeah, I see the haptic guy back there shaking his head.
If you want to see, I can show you what really got me into the telepresence. I have a video of it. It's a little telepresence robot.
Yeah, okay.
Video of it.
Well, why don't we look at that at the end of the meeting? That'd be cool. But yeah, so basically it limits the amount of difference to a very small threshold, but it's enough to be able, I think, to kind of feel. I don't know if you folks who felt it, do you feel like you're feeling somebody kind of on the other end? Huh? Kind of. Okay, that's good. Okay.
2 questions. One, it depends on the static IP address at both ends, right? So it doesn't change or renew the least mid-stream.
It depends on a static. No, the only static IP address is the server. This is DHCPing an IP address each time. Now the truth is, actually, I faked the stat. Now it has a static IP address to go to my laptop, but in standard operation and on the other side right now, it's DHCPing an IP address, and that's how it's made. So you can plug into any reasonable router. You can plug it into, it'll DHCP the IP address and get going.
And as far as the export, you say you're dealing with UDP, not TCP, right?
Yes, I'm just doing UDP.
And the difference in handling both those would be what, in terms of changing what you have there?
Well, in TCP, you create a connection, and the connection keeps going. And if you drop any packets, of course, they get automatically retransmitted by the IP stack. In UDP, you just kind of throw a packet out there, and 99.9% of the time it'll make it, and then sometimes it won't. But that you don't have to worry about this continuous connection being made. I just find it easier to work with. It could have been done in TCP as well.
So maybe it would have taken just a different module in your Python program.
Yeah, different module in the Python program, you have to configure the export to use TCP rather than UDP. But yeah, exports are perfectly capable of creating TCP connections. They also run their own little web server on board. So if you hit it on port 80, you can actually, it has 2 or 3 digital IOs built into it. So you could actually make a very simple Phy2Phy project like the slapper if you just have like one pin going high to do the slap. All you need is just one export. You don't need a microcontroller at all. You might need a server, though, to kind of do some interpretation in the middle. So, okay, in the back?
How are you handling your servo control, and what's the power limit on the servos? Namely, how much power does the servo draw, or how much can the project deliver?
I don't really know. It's on a 5-volt. It's on a 5-volt regulator, and probably if I was pulling like an amp or two, it would probably start to get warm. So there's very little power on these RC servos. They're not really capable of a heck of a lot. You can buy these things, actually put them into gears and have a lot of torque. But again, in terms of the amount of power you're delivering to the servo, not a heck of a lot. These are made for airplanes and cars and stuff like that. Model airplanes, model cars. Huh?
So you've been working on the hardware and everything. How much thought have you given to like a sort of a protocol for this, so that people can build their own different actuator sort of things and hook them up through your circuit?
The question was about protocols. I've not thought deeply about it. However, just having authored an RFC about a year ago, I've been thinking about it because now I know how to do these things. I put in a joke RFC, right? So isn't something I've been thinking about. But no, today I've not established any standards for this. Right now, the packets are 2 packets big. Sorry, 2 bytes coming from here. One is the finger number, and one is the pressure. And then coming back, it's 1 byte, and that's the position of the servo. It's a very, very simple protocol right now, nothing complex. In the front?
You have to program the export, or does it come configured for you someplace?
I mean, the export's ready to go, but you do have to configure it. You have to tell it what IP address it needs to connect to or send packets to.
Right.
And you also have to make sure it's set for the right baud rate for the, or bits per second rate, whatever you want to call it, for the serial connection.